Hey guys, last lesson for Unit 7 here. We're doing Lesson 15, Distinguishing Volume and Surface Area. There's nothing new. We're just going to be solving surface area and volume problems. And then there's going to be some problems where they ask us which one are we trying to figure out, surface area or volume. So here we go. If we look at page 119, section 1, it says the science fair. It says, my science teacher told her that when there's more ice touching the water in the glass, the ice melts faster. She wants to test this statement, so she designs her science fair project to determine if crushed ice or ice cubes will melt faster in the drink. She begins with 2 cups of warm water. In 1 cup she puts a cube of ice. In the second cup she puts crushed ice with the same volume as the cube. What is your hypothesis? Will the ice cube or the crushed ice melt faster, or will they melt at the same rate? Okay? The more ice that touches the water, the faster it's going to melt. Okay? You could even try this at home if you wanted to. You could put a glass with just cubes of ice in it, and then you could put a glass with crushed ice in it. And the crushed ice, because more of the ice is touching the water, the crushed ice is going to melt faster than the block of ice. So my is right. The crushed ice is going to melt faster because there's more ice touching the water. Okay? Now we're going to skip some here, and we're going to go to 15.4 on page 121. Alright, here we go. 15.4, wheelbarrow of concrete. It says a wheelbarrow is being used to carry wet concrete. Here are its dimensions. So we have the side view. So this, right here, this trapezoid is the side of the wheelbarrow. So it gives me the dimensions of the trapezoid, and then it gives me the depth and how wide it is on top. Okay, so what is the volume? So volume is how much we can fit into it. So remember, volume is the area of the base times your height. Okay, so the base are the trapezoids on the sides. Okay, so I need to find the area of a trapezoid and then multiply it by how deep it is. So area of a trapezoid, we haven't talked about this. The formula is the height times your bases added together. So on a trapezoid, there's 2 bases, the top and the bottom. Those are your bases. So we're going to add those up, multiply it by how tall it is, and then divide that out by 2. So my height is 66. Ooh, that's kind of ugly. Let's redo that. My height is 66. My base 1 is the top, 140, all added together, plus my bottom, 40, and then divide that by 2. So if I grab my calculator here and go 140 times 40, I get 180. So I go 180 times 66 divided by 2, I get 5,940. So the area of the base on this one is 5,940. Okay, now I'm going to multiply that by how deep it is, or how long it is, the length between the 2 bases. So my length here is 70. So I'm going to go 5,940 times 70, and that will give me the volume, how much concrete I can fit in there. So 5,940 times 70, I get 415,800. So 415,800 centimeters cubed. Okay, so that's volume. That's number 1. Number 2 says, after dumping out the concrete, you notice that there's a thin film left on the inside of the tray. What is the surface area, or what is the area of the concrete in the tray? Remember, there's no top. So we need to find the surface area of the inside of the wheel. So if we think back to the volume problem, we figured out that the trapezoids, the two sides, are 5,940. So there's two of those. Let me get a marker out. 5,940 for the front, 5,940 for the back. Now I just need to find the two sides and the bottom. Remember, there is no top, so I don't need to find the area of the top. So the area of the side right here is 70, and this length is this length over here, so it's 93. So once again, taking my calculator, I go 70 times 93, and I get 6510. So the red rectangle is 65. Whoop. Let's match this up here. 6,510. Okay, the bottom is 70 times 40. 70 times 40 is 2,800. And then the right side here, still 70. But if we look here, this length is 74. So if we go 70 times 74, we get 5,180. Now remember, we don't have to do the top because it's a wheelbarrow. So let's add those all together. 5,940 for the two sides. 1,940 plus 6,510 for the left side of the wheelbarrow, plus 2,800 for the bottom, plus 5,480 for the right side. We get 26,670 centimeters squared, because we're talking surface area. Okay, and that's it. So there's nothing new. Remember, to find the volume, we go the area of the base times our height. To find the surface area, we find the area of all the sides, and then we add them together, just like you did in yesterday's assignment. Okay, so let's look at the summary. It says, sometimes we need to find the volume of the prism, and sometimes we need to find the surface area. Here are some examples of quantities related to volume. How much a water container can hold. How much material it took to build a solid object. Volume is measured in cubic inch units, like inches cubed or meters cubed. Here are some examples of quantities related to surface area. How much fabric is needed to cover a surface. How much of an object needs to be painted. Surface area is measured in square units, like inches squared or meters squared. Volume, we're filling something up. Surface area, we're covering something up. Okay, so let's look at the assignment. Number 1, we are going to do letter A. So it says that the height of the prism is 5 centimeters. What is its surface area, and what is its volume? So remember, volume is area, the area of your base times how tall it is. Okay, surface area is all the sides added together. So there is no formula for this this shape right here. So I'm going to break it up into 3 rectangles. The bottom 2 are identical, and then we have the top skinny one. So this is not 5 anymore. The bottom here is 2, right? 2. So 5 minus 2 is 3. So the top here is 3. So 8 times 3 is 24. And 2 times 3 is 6. 2 times 3 is 6. So if I'm trying to find the surface area, if I go 24 plus 6, it's 30, and 30 plus 6 more is 36. So both bases are 36. Okay, now I need to find the area of all the sides. Well, it doesn't give me a picture, but it says that the sides are 5 centimeters tall. So all I'm going to do here is take each one of the sides of the shape and multiply it by 5. So 8 times 5 is 40. 5 times 5 is 25. 3 times 5 is 15. 2 times 5 is 10. 2 times 5 is 10. And 2 times 5 is 10. 3 times 5 is 15 again. And then 5 times 5 is 25 over here. So these are the sides. So I have 36 and 36 for my bases. and then 25, 40, 25, 15, 10, 10, 10, and 15 again. So I'm just going to take my calculator and add them all together. So here we go, 36 plus 36 plus 25 plus 40 plus 25 plus 15 plus 10 plus 10 plus 10 plus 15 more. I get 222 centimeters squared. So that's the surface area, 222 centimeters squared. The volume is the area of the base, which we know is 36, times the height, which we know is 15. So all we got to do for volume is go 36 times, or not 15, 5. 36 times 5, and we get 180 centimeters cubed. So there's one. Surface area is 222 centimeters squared. Volume is 180 centimeters cubed. Okay, let's look at number 2. We're going to skip B and C on 1. We'll move to 2. So it says select all the situations where knowing the volume of the object would be more useful than the surface area. So letter A, determining the amount of paint needed to paint a barn. If we're painting a barn, we're covering it. So that would be surface area. So that is not volume. Letter B, determining the monetary value of a piece of gold of jewelry. Jewelry, piece of gold, it's all made out of gold, right? So that would be volume. Gold jewelry, it's all made out of gold. So that's how much gold it takes to make the jewelry. So that would be volume. Letter C, filling an aquarium. Filling, we're filling something up. So that'd be volume again. Letter D, deciding how much wrapping paper to give. So we're covering it, so that would be surface area. Letter E, packing a box with watermelons for shipping. Packing a box, so we're filling the box, so that's volume. Letter F, charging a company for ad space on your race car, so you're covering your race car with an ad, so that would be surface area. And letter G, measuring the amount of gasoline left in the tank of a tractor. Well, we fill up the gas tank, so that would be volume. So surface area, volume, volume, surface area, volume, surface area, volume. All right, and there you have it. We'll have a quiz tomorrow on the 2 sections of 14 and 15, and then next week we will start Unit 8, Statistics and Probability. Remember, if you have any questions, just go ahead and email me, and I will be happy to help. Thanks.